In this section, we'll introduce you to the DLT pipeline that we've already built, and we'll make sure that you can run this pipeline successfully on your own local machines. This is really important because if you're not able to run this as a Python script on your computers, you won't be able to deploy it on the subsequent orchestrators. So the main goal of this section is to make sure you can do just that. Let's get into a bit more detail as to what we'll cover in this section of the course. First, of course, we'll introduce the problem statement that we'll be addressing with our DLT pipeline. Then we'll go over some relevant terms and concepts that you should understand in order to be able to interpret our DLT pipeline script. And then we'll actually show you that script and break it down bit by bit. And finally, and this is probably the most important part, we'll actually walk you through how you can run it. Now, even though we've built the script, if we run it as it is, then it's not going to work because we've done no setup. So we're going to show you how you can set up the environment and get all the credentials and provide those credentials to the script as part of the walkthrough. So let's move on. You're already familiar with this visual. Our DLT pipeline is going to pretty much do just this. It's going to collect data from the GitHub API, and it's going to store it in BigQuery. Let's just add a few more details, though. Firstly, we'll be collecting data from 5 specific endpoints in GitHub. And for the issues endpoint, we'll be incorporating incremental loading. And for the forks endpoint, we'll make sure that we can implement backfilling if we want. And finally, in order to make it easier to debug and monitor, we'll enable logging for the pipeline runs. So let's cover some terminology. Firstly, we have cursor. In DLT, cursor is a field in our data. It's normally a date or an ID, and it basically serves as a bookmark. It tells our DLT pipeline where the last one stopped. Now, I really like the analogy of a bookmark because imagine if you're reading like a really big book and you get halfway, but you don't recall exactly where you stopped reading. Well, the normal thing to do is to take your time and find the exact page where you stopped reading and basically start from there. What you wouldn't do is go from page 1 and then start reading all over. That's just a waste of time and effort. Well, that's pretty much what DLT will do by default if you don't have or use a cursor. So a cursor is really important for these following techniques. First is incremental loading. So incremental loading is a technique where you only fetch new or updated data since the previous run. And incremental loading uses cursor to track changes. So let's say that your data has a date field as a cursor field. And let's say that we've collected data up till September 17th. Well, the next time we run this pipeline is not going to collect data that was from before the 17th of September. Rather, it's only going to collect data from the 17th onwards. And this is great because it means that you're avoiding redundancy, you're making fewer API calls, and you're able to run pipelines quicker. So this is a technique ideal for ongoing pipelines, basically pipelines that you run periodically, could be hour or daily. And the second technique is backfilling. Backfilling is a technique where you reload data from a very specific time window to fill in any gaps or repair history. And this window, of course, is defined by your cursor field. This can be important because your data as it is might have gaps or missing values, or your source may have applied new logic that your current data hasn't really accounted for. Backfilling is a great way to remedy those issues. Unlike incremental loading, which you would likely perform repetitively, backfilling is more suited for one-off jobs. Basically, it's not something that you would do over and over. Instead, once you have addressed all the gaps in your past data, you can disable backfilling. Okay, enough theory. Let's actually look at the code that you'll be using throughout this course. Again, this is something we've written for you in advance, so you don't have to create anything yourselves. You can simply access this through README files and also learn roles. So just as a quick reminder, we're creating a pipeline that collects data from GitHub and stores it in BigQuery. Let's actually take a look at how we're doing this. Our first step, of course, is to define our config. Our config is where we give the DLT pipeline all the information it needs regarding the data source, which in this case is the GitHub API. I won't go everything line by line, but I'll point out the important stuff. So first, of course, we are giving it the base URL, and we're also giving it the access token. So the access token is really important because without it, you will hit your rate limit and your pipeline will fail. I'll show you how to get your access token a bit later on, but let's move on. Next, in the resources key, we're giving it all the information on the endpoints for this API that we'll need. So in this case, that's the repos, contributors, issues, forks, and releases. So like I said, that's 5 endpoints. And once we give all this information through our config, we'll create our source object using the REST API source function, which we'll store in this variable called GitHub source. In the next section, we are defining our pipeline object. We give it important pieces of information, such as the name of the pipeline, the destination, which of course is BigQuery. And also one thing that's worth mentioning is this line here called progress equals log. Like I said, we want to be able to understand what's going on with our pipeline, so it's easy to monitor and debug. So this log will give us all that information. And then finally, we run the pipeline. This is all pretty simple, right? So let's talk about how we're implementing some of the techniques that we discussed before, namely incremental loading and backfilling. So first, let's talk about incremental loading. I'm going to go back to our config, and I'll hone in on one specific endpoint, which is issues. In this pipeline, we will be carrying out incremental loading for all the GitHub issues. That means we'll only be collecting data that we haven't already collected. So that's going to save us a lot of time. It's going to mean fewer API calls. And yeah, it's a good inclusion. So how we do that is shown in the config itself. So firstly, I'll point out this section here, this key called cursor path. As we recall, cursor is the field that we use to define what we need to collect. In this case, it's the field called updated at, which is a date field. So it's pretty appropriate. And we also assign it an initial value. Next, we are also telling it we're giving it the logic for incremental loading. So here we're saying that we want to start collecting data from the start value. And again, the start value in this case serves as the bookmark that I used in the previous analogy. It basically shows us where we can continue our data collection. Let's move on to backfilling. Backfilling is a bit different from incremental loading, as I said, because you don't actually perform backfilling repetitively. It's usually a one-off job. So it really doesn't make sense to put it in the config directly because then it'll mean that you'll keep backfilling nonstop, and that's not really sensible. If you like, you can actually tweak the config after you've created the source. In this line here, we create our GitHub source. And we give our config to this function REST API source, and as a result, that creates a source object. The cool thing is, even after this line, even after we've created our source object, we can still add more rules, add more constraints to the config. And that's something I'll show you later on. If you want to veer off and add one-time jobs, then you can easily do that by modifying the GitHub source without actually tampering with the original config. Now I'm going to show you how you can run this code on your own local machine. So as you can see, I've opened up VS Code, and you can use the IDE of your choice, VS Code, PyCharm, Cursor, it's all the same. So first thing I'm going to do is I'm going to create my virtual environment, and I'll be using EUV throughout the whole thing for convenience. So Once I create it, I activate it. And now I want to install the dependencies needed to get this DLT pipeline running. So I forgot the actual command for that, so I'm going to head over to the documentation. So I'm going to the DLT website, open docs, and I'm just going to type BigQuery destination. And here we are, and here's the command. So let me copy that and head back. I'll add UV before the pip install, and I'll just enter. Okay, great. Now that we've installed DLT, we can create our DLT project. And here's how that looks like. So first, we do DLT init. Oops. We do DLT init. And then we basically name our project. So I'm going to call it, I don't know, demo project. And after the name of your project, you add the destination. So in our case, the destination is BigQuery. So I type BigQuery and now hit enter. Proceed. Great. So let me clear this and then let's go over what we have here. So first, of course, we have our DLT folder with our config and secrets. We'll be playing around with this a bit later. And then we also have a gitignore, a requirements.txt, and our demo project pipeline. So this is a pipeline that comes with the init command. Of course, we won't be using this. Instead, we'll be using the code that I showed you previously. So let me bring that in here. So I'll be taking all of this. Oops. Sorry for the aggressive scroll. And I will paste it here. Great. So we're already halfway there. However, if we run this now, it'll naturally fail. And that's because we haven't given it the credentials. We haven't given it the credentials for GitHub, basically the access token, and we also haven't given it the BigQuery credentials, which it will need in order to run this pipeline. So let's work on getting those. I'm going to be getting the credentials from both GitHub and GCP now, and I'll be putting them in the secrets TOML file. So let's start with GitHub because that's just easier. So I'm going to switch over to my GitHub profile, which is here. And if you don't know how to, and I'll go to settings. So if you don't know how to get to settings, click on your profile pic on the top right and just click on settings and you'll find yourself there. After that, scroll all the way down until you can see on the left tab or the left bar, developer settings. I'll click on that and I'm just going to click on personal access tokens and then just tokens classic. What I'm going to do now is generate a new token and I'm just going to use it for general use. So I'm just going to call this, course demo because that's, So now I'm going to generate token. I'm not going to click on anything else. And once you generate this token, you'll be given it naturally and you won't be able to see it again. So what I'm going to do is I'm immediately going to copy it and I'm going to switch over to our project and I'm going to paste it here, right? And that's it. So, well, that's not quite it because in order to access this key, we need to make sure that the naming conventions in our secrets TOML matches, how we're accessing them with dlt.secrets. So here you can see from our code, we're accessing our secrets through the key sources.key token. So our secrets.toml has to match that. So let me switch over. So firstly, the name of the variable itself has to be access token. And in the brackets above, how to use brackets? Yep, there we go. In the brackets above, it's going to be source. It's going to be sources, right? So Now, when I ask it to access sources.access token, it's going to go to the secrets toml file. It's going to look for the sources bracket, and then under the sources bracket, it's going to look for the variable called access token, and it's going to take the values there and use that. So that's the gist of that. Now let's move on to BigQuery. As you can see here, we need three specific variables. We need the project ID, the private key, and the client email. So let's work on getting those. And my memory is not great, so I'm going to be using the documentation to help me out a bit. Let me switch over to that. Okay, so if you recall, I used it to get my pip install command, but now I want to see how I can get all those pieces of information that I showed you before. So it seems like I have to log into GCP, create a project, create a service account, and grant it these specific permissions, and then download the JSON. Okay, so let's do that. I'm going to head over to the GCP account for DLT, and so in my case, I already have a GCP account and I already have a project created. So if you haven't done those things already, please do so. Again, it won't cost you anything if you are on the free tier. So the first thing I'm going to do is, like it said, I need to create a service account. I'm going to go over to the navigation menu. I am an admin and service accounts. And I'm going to create a service account. Again, I'm just going to call this orchestrator. I think that's how you spell it, demo. And I'll add a suffix, delete later, because I need to delete this after the course is complete. Otherwise, I'll be in trouble. Let me move on to permissions. Oh, let me click create and continue actually. Now let me move on to permissions. As you recall, there were three permissions that I need to provide the service account. So let me just jog my memory. So it needs to be the data editor, the job user, and the read session user. So let me first look up data editor. Now let me add the job user. Oops. And I bet the last one was data session. Oops. Read session user. My apologies. Read session user. There we go. Now, I believe there's nothing more I need to add to the service account. So, okay, yeah. So we can just move on to done. And once I'm done, I just need to find this orchestration demo, delete later, service account I created, and I need to download this JSON to get all the credentials. So how I can do that is I can go to keys and I can add a key and create a key. Again, it needs to be JSON, so I'll create this and it'll be downloaded, right? And in this key, I'll just open it up for you. So this is what your JSON looks like. It has all these different fields. As you can see, it has the information that we need, like project ID, private key, and client email. So I'll copy the project ID and I'll switch over to my project and I'll plug this in. Next, I'll go to private key, which is pretty big. It's all this. And then I'll paste it. I just noticed the double quotations for my project ID. Let me get rid of those. And then we have the client email. There we go. So now we have all our credentials, both GitHub and BigQuery. So if I haven't missed anything, this should be able to run without error. Okay, so As you can see here, I'm in my BigQuery. If you don't know how to open this page, all you have to do is type BigQuery in the search bar, and you'll find the BigQuery product in the top result. If you click on it, you'll find yourself here. And on your left, you'll be able to see all the databases that have been created. So if I scroll down, you'll see there's no database called GitHub Data, and that's going to be the name of the database we create. Let me switch back to our code. So you can see here we are calling our data set GitHub Data. What that means is when our pipeline is done running and loading its data, it'll be done in a place called GitHub Data. So let me run this pipeline. And now this is what I was referring to when I was talking about the logs. Let me just make this a bit bigger. So here we're actually showing you through the logs what's happening when we click pipeline.run and to run the pipeline. So on the top, you can see what phase the pipeline is in. So here, for example, it's extracting data. And under it, you can see all the different endpoints. And next to these endpoints, you see a number associated with it. So this number corresponds to the number of data items collected for that endpoint. So it's going to keep collecting data until there's nothing more to collect. Right. So now, as you can see, this is the last extract log, and now it goes from extract to normalize. And in normalize, that's when it does all the transformations, such as flattening, whenever applicable. And then let's keep going down. And once it's done normalizing, it's going to load it in BigQuery. So once that's done, it'll confirm completion and that, the pipeline was run with no issues. So if I go back to my GCP BigQuery, refresh this, and then head back down, I should be able to see GitHub data. And let me expand on this, and you'll be able to see all your endpoints. You'll be able to see all your flattened data that's denoted by these double underscore, and you'll also be able to see the fields that are created, or sorry, the data tables created by DLT itself. So if you want to open one of these, all you have to do is, let me run this, and there we go. We have our data. Let's now talk about backfilling. So as you know, backfilling is usually a one-off job. This isn't this type of thing you include in the main config, but if you, for example, in the middle of your pipeline runs, at some point decide, I want to collect data at a specific time window for a specific endpoint, well then you can actually tweak the config after creating the GitHub source. This is what that will look like. So in this line here, we create a object called GitHub source, and we can apply backfilling by using this GitHub source object, and we'll do it only to forks. So here's what that's going to look like. First, of course, the name of the source object, then the name of the endpoint. So in this case, it's forks. And I'm getting that value here in case you don't know. And then I'm going to use the function apply hints. Now, apply hints is the function that's making all of this possible. If you want to learn more about it, you can check out the DLT documentation. Apply hints can be used for more than just backfilling, but that's what we'll be using it for in this case. So inside apply hints, there'll be a parameter called incremental, and to this I'll assign dlt.sources.incremental, and followed by a parentheses. Let me make sure I have the right number of parentheses. I don't. So one here, sorry, one here. Okay, there we go. And now here, I want to provide all the information that I am already providing here with a bit more. So let's start with what we have already provided in the original config, and that's the cursor path. That's one. Oops, that should be in parentheses, which is created at. Next is initial value, and I'm going to use the same value here. And then I'm going to have end value, right? Because in the original config, we're giving it the path and the initial value, but in a time window, you need both an initial value and an end value. Without both of these, you don't have a time window and you can't perform your backfill. So here, we're actually going to provide an end value, and this will be arbitrary. Here, the initial value is the 1st of July, so I'm just going to make the end value the 1st of August. And finally, I'm going to say row order equals to ASC. And all that means is we'll be collecting data from the oldest to the newest. So that's going to be that. I missed a comma here. Okay, and just like that, we have our backfill implementation. So let me open up a terminal with Command J, and let me run the pipeline again and just see if this works. And there we go. While we can see the logs, there's something else I wanted to point out to you, and that is in the logs. You can see this time, if you look at the issues and the number of data points we're collecting, it's a lot fewer than what we collected before. And once again, that's because of incremental loading, because our current destination, our BigQuery database, already has the majority of the issues from our previous run. So when I run this exact same code going forward, it's only going to collect the issues that haven't already been collected. If you recall, the goal of this section of the course was to get you to be able to run this script by yourself on your machine. Don't even worry about backfilling. That was a supplementary code snippet that we added, but you should be able to run the original script that we'll be providing you through our GitHub repo.